Hey, welcome back to your favorite intermediate algebra course. We're going to add and subtract matrices today, multiply matrix by a scalar, and solve some matrix equations. So with this first example here, if we're comparing matrices, to be equal matrices, you have to have the same entries. Okay, so if you look at, and the same dimensions. So first of all, the dimensions are rows. You notice you have two rows here by, in this matrix, two columns. Two rows by two columns. So this is a 2 by 2 matrix, okay? Two rows by two columns. So you're comparing this other one, you say, well, is this other one rows, two rows, how many columns by two columns, okay? So they're both the same dimensions, okay? Now we just got to see, are the entry is the same. So first row, first column, 0.25. Is that the same thing as 1/4? Yes, it is. First row, second column there, 2, 2. They're the same. Look at the 1, compare it to the second row, the first column, 1. And finally, -3/5. Is that the same thing as -0.6? Sure, -0.6 is -6/10 or -3/5. So yes, they are. Yes, they are equal, so I put a little equal sign between those two. Okay, now the second one, are these matrices equal? And I say, well, they're both 2 by 2 matrices. And we'll talk more about dimensions later as well in the next section. Are they equal? Look at the first entry there. Is that the same as that? And you're like, nope, it's not. So right away, I don't even have to look at anything else. Those matrices are not equal. Okay, to add and subtract matrices, you must have the same dimensions, first of all. So let's look at this first A here. We're trying to add these up. We're trying to add these matrices. So are the dimensions the same? I say, well, how many rows do I have? I have 2 rows. How many columns do I have? 1 column. So I have a 2 by 1 there. 2 by 1 on that matrix. Let me write it again. 2 by 1. Over here, it looks like I have 2 rows by how many columns? 1, 2, 3. Okay. So I have a 2 by 3 over there. So I cannot even add those things because they don't have the same dimensions. First one's a 2 by 1, second one's a 2 by 3. Can't even do it. So cannot, different dimensions. All right, over here though, both of those are 2 by 2. So let's go ahead and subtract these. So I go take the first entry, 3 minus the -1. 3 minus the -1, and that goes in the same position where I found those entries. Now I go -2 minus 2. Now we jump to the second row, first column, 0 minus 5. And finally, second row, second column, -2 minus 3. And then we just clean it up. 3 minus the -1, 3 plus 1, 4. -2 minus 2, right there, -4. 0 minus the 5, -5, -2 minus 3, -5. So there's our solution to adding those two matrices. Okay. Now, what if you're multiplying now? Okay, so we've done a little subtraction there, addition, subtraction. What if you're multiplying? This is called scalar multiplication because you have a scalar out front. You have that constant right out front, that 2. Well, all you do is you take the scalar through to each of those entries. So you take the 2 times the first one, 3, and then you take the 2 in front by the 2, and then you'll take the 2 in front times the -1, and then you take the 2 in front times that 3. And that'll be your solution. So you got 2 times 3, 6, 2 times 2, 4, 2 times -1, -2, 2 times 3, 6. That's how you do scalar multiplication, okay? Now let's do a combination of scalar multiplication as well as subtraction here. So let's take the 3 in front by each of those terms. So 3 times 1 is 3. 3 times the next one, 3 times 2 is 6. 3 times 2, 6. 3 in front times the -2, -6, and 3 times the 3 there, 9. Okay, so you'll follow your order of operations. We're going to do the multiplication before we do the subtraction. Okay, now we do the subtraction. 3 minus 2 is 1. 6 minus 6, 0. -6 minus a -6 is -6 plus 6, so 0. And finally, 9 minus the 8 is 1. And there it is, 1, 0, 0, 1, the identity matrix for a 2 by 2. All right, now what if you're solving for x and y there? You notice that the 2 is out in front, and you got parentheses around those 2 matrices inside. Well, I'm going to do this where I do the, the please excuse my dear Aunt Sally. So I'm going to do inside those parentheses first. Instead of distributing the 2 to each of those, although I could use that distributive property because the distributive property holds here. But let's do the addition first, okay? So leave the 2 out in front for a minute, and I got -2 plus y, -2 plus y. And then I got the 3 plus the 7, so I got 10. And then I got x plus -4. X plus a -4 is just x minus 4. And then I got the 5 plus the 10, so 15. Okay? Don't forget we still have that 2 out front, right? And this all equals, I just bring this along over here. Now do the scalar multiplication. So the 2 goes into each of those, that -2 plus y. And then the 2 times the 10, 2 times the x minus 4, 2 times the 15. This stuff stays the same. Okay? Distribute that, -4 plus 2y, 2 times 10, 20. Distribute that, 2x minus 8, and 2 times 15, 30. And then we have this is equal to -10, 20, 10, and 30. All right, now we're at this point. You notice I have a 2 by 2 matrix on the left, 2 by 2 matrix on the right, so these entries must be the same. That -4 plus 2y is equal to -10. Now I can solve for y. 2y equals -6. Divide by 2, y is -3. Okay, so we got our y value, and then you notice here's where my x is. 2x minus 8 must be equal to 10. So x is 9, right? Add 8 both sides, divide by 2. So there's x, there's y. We just solve that for x and y. Now here's your properties that hold for operations of matrices. Okay, the associative property holds. So that capital A, capital B, capital C, those are all matrices. So if you take matrix A plus a matrix B plus a matrix C, right? And if you take those two and you do those first, and then you add it to matrix C, well, that's the exact same thing. You'll get the exact same thing as doing the last two first, and then adding it to the first matrix, okay? So the associative property holds, the commutative property holds with matrices, the distributive property holds, and then the distributive property, and they, you can look at, you can call it just the distributive property, or you can, denote it like your authors have, distributive property of addition, distributive property of subtraction there. Okay? All right, make sure you guys bring your questions.